Section 7.2 is called Similar Polygons, and we have two learning objectives. The first is going to be identifying similar polygons, and the second is then using that similarity to determine requested values. So the first thing we have to do here is we have to go through some vocabulary. We have 4 vocabulary words. The first one is similar figures, and these are two things that are going to be the same shape, but not necessarily the same size. Then we move into similar polygon, which is just a little bit more specific. It's still going to be similar figures, so still same shape, not necessarily same size. But now also we add the idea that there's all congruent angles and sides that are proportional. So if you look at this example that's included here, I have 3 pairs of congruent angles, and all of my sides are proportional. If I take the smaller triangle and I multiply each of those values by 2.5, I will get the values in the larger triangle. 8 times 2.5 is 20, 6 times 2.5 is 15, 10 times 2.5 is 25. And then we have here, triangle ABC is similar to triangle XYZ. This little sign, that's like the little squiggly or the tilde, that means similar. Now we also have this thing called an extended proportion, and that's when 3 or more ratios are set equal to each other. And then the last thing we have is a scale factor. And a scale factor is the ratio of the corresponding linear measurements. So, for example, back up here, my scale factor would have been 2.5 because I took all of my values in my smaller triangle, I multiplied them by 2.5, a scale factor of 2.5, to get to my larger triangle. So let's look at an example here. I have a picture given to me. I also have this similarity statement. And again, notice I have this little tilde, meaning that I have similar triangles. So if I look at the picture, it appears to me that this smaller triangle has just kind of been like rotated and shrunk from this bigger one. So I can kind of tell that N corresponds with R, and that M corresponds with S, and that P corresponds with T. So I can tell from the picture there. However, sometimes the pictures are really hard to determine, like what's happening. So as long as they give me this similarity statement, I have all of the information that I need. If I'm looking for my congruent angles, M is my first letter, S is my first letter. So I know that angle M is congruent to angle S. Angle N and R are going to correspond there. So angle N is congruent to angle R. And lastly, angle P congruent to angle T. So those are the pairs of my congruent angles. Now for my extended proportion, I need to be looking at my sides. So let's put that in parentheses here. I'm looking at my sides. And what I'm going to do is I'm just going to take each side of the triangle and match it up to the one from the other triangle. So my first 2 letters are M, N, and S, R. And I know those are going to be equal to my next 2 letters, N, P, and R, T. And then my first letter, P, M, and T, S. Now what's important is that these are all the letters on top from triangle MNP, and on bottom is always going to be triangle SRT. I can't mix which triangle I put on top and which triangle I put on bottom. So now you're going to go ahead and do this you try where they give you not similar triangles, but they give you similar quadrilaterals, 4-sided shapes because there's 4 letters given to you there in the names. So go ahead and do that you try, and I'll check that in class. And now we're looking at how to determine similarity. So in the last example, they told us, hey, these things are similar, and we were able to pick out which things would be congruent and what my extended ratio would be. Now here, though, I need to make sure, given this picture, do I have similar figures? So the first thing I have to do is I have to check all of my angles. Angle, angle, congruent, angle, angle, congruent, angle, angle, congruent, angle, angle, congruent. Okay, cool. So let's write those down real quick. I know that all of my angles are congruent. I've got angle U congruent to angle K, and that's a U, it looks like a V. Angle U congruent to angle K. I've got angle T congruent to angle J. I've got angle W congruent to angle, oh, there's no letter there, JKL. Let's call that M. And then I've got one more pair, and that's going to be angle V congruent to angle L. So there's my 4 congruent angle pairs. And now I also have to check my ratios. So let's set up all of our ratios and see if we end up getting the same value when we reduce our fractions. So I've got 16 over 24, and that comes from these two sides here, and that's going to have to be equal to 6 over 12, which are these two sides here. And then next I'm going to do this side to this side, so 6 over 6. And then the last one I have is 14 over 24. Okay, so right away I see something's wrong. I don't even really have to reduce. All I have to do is think in my brain, because I know 6 over 12 reduces to 1/2, and 6 over 6 is clearly 1. So obviously these are not similar figures, because my ratios right off the bat, I know I don't have something that's similar. As well as here, 16 over 24 and 14 over 24 are clearly not going to reduce to the same thing. So I can say that these are not similar figures. And then you also have a U try there. So the next thing we're going to do here is we're going to take our ratios and we're going to set them equal to each other so we have a proportion which can help us solve for variables. In this first example, they tell us that ABCD is similar to EFGD, which tells me that when I set up my ratios, they must all be equal to each other. I see that I have a smaller trapezoid inside a larger trapezoid. So what I'm going to do is I'm going to give myself a little reminder, first of all, that when I write my ratios, I'm going to write them with my small values over my large values. And what that means is my small values are pertaining to this smaller trapezoid. My large means its values pertaining to my larger trapezoid. So I'm looking for a ratio that I can set up with solely numbers. And I see this 6 and this 9. What that tells me is that all of my ratios should be 6 over 9. So then when I look for my x, I see it right here. It corresponds to this 7.5. So I'm going to set this equal to x over 7.5. And then I'm going to go ahead and I'm going to cross multiply. We learned last section that that's how you solve a proportion. This gives me 9x equals 45. And if I divide by my 9, I end up with x equals 5. So all I did is I set up a proportion using two ratios I could determine from this picture so that one of them included x and the other one was a straight up ratio which told me how I needed to relate that x to the 7.5. I got my answer of 7.5 by my answer of 5 by cross multiplying and dividing by 9. So then you just have to do this U try, and I will check that in class. Other than that, that's the end of this section.